Happy Wednesday, guys. So today we are completing the square. So we're still solving, right? Anytime you see solving when it comes to quadratics, we're talking about solutions, roots. Try and think of the other names before I write them down. Zeros and x-intercepts. Right? Those are all the same words for I just want to solve for x. Okay? All right, so let's figure out what this means. So think back to when we solved perfect square trinomials. Now, I did put some steps here, but they are listed out a little bit more detailed on your actual worksheet. So please have that out. Remember, you should always have done or at least attempted those problems before watching the video. Okay? All right. So the first section, they actually made it kind of easy for you. And they made sure that on one side, you already had a perfect square trinomial. Okay? So remember that perfect square trinomials have identical factors. Just like the number 16 has factors of 4 times 4, identical numbers, right? X squared plus 4x plus 4, they will have identical factors inside the parentheses, okay? And if you're not sure, you can put them in that box, right? And in this particular case, that box should be a perfect square. All right, so I'm going to do x squared, okay, the first term in the first box, last term in the last box. And if you notice, both the first and last term are perfect squares. So the square root of x squared is x times x. And then if I took the square root of 4, I'd get 2, right? 2 or negative 2, right? But in this case, I want to add to get a positive 4x. So I'm going to have plus 2 plus 2. All right, so now I have x times 2 is a positive 2x. And here, 2 times x is also, remember, that's identical, the same thing, right? We're talking about a square. So my factors for x squared plus 4x plus 4 form this perfect square where I have the factors of x plus 2 times x plus 2. Again, they are identical. Now, on the other side, they actually gave you a perfect square term here. So why is 25 a perfect square? Right? If I put the 25 in this square, I would have factors of 5 times 5. Okay, so you can use area method for really anything, right? It's just kind of showing you what's inside is the area and what's outside are the factors. Okay. All right, so we have x plus 2 times x plus 2 is equal to 5 times 5. All right, so I'm just rewriting, instead of 25, I'm rewriting its factors, and I want to have identical factors here. Okay, I'm trying to get that square. That's why it's called completing the square. Okay, now I'm going to rewrite these factors with that square root. Oh, sorry, not the square root, with that square attached to them, okay, with the exponent. So instead of x plus 2 times x plus 2, I'm just going to write x plus 2 squared equals, instead of 5 times 5, I'm just going to write 5 squared. Now, if you want to, you can make sure that 5 squared is 25, use your calculator, and that x plus 2 times x plus 2, put it in that y equals, graph it, and it will give you exactly the same quadratic as this here. Okay, So, like always, I need more room, so I'm about to erase this. And so make sure that if you need anything, copy it down. Okay, so I'm just going to rewrite this as x plus 2 squared. And I'm going to rewrite this as 5 squared. Okay, you could keep it as 25. I mean, that would be fine too. All right, so now I want to solve it using that square root method. Okay, remember, just like plus and minus, the square and the square root cancel out. So I'm going to just do square root and square root. All right, so here we just have a cancel out. So we have x plus 2. And now here it's a little tricky, but you have to remember that this could be 5 squared or it could be negative 5 squared, right? Remember, negative 5 times negative 5. Let me write that up here. Oops, sorry guys. Negative 5 times negative 5 is also a positive 25. Okay, just like 5 times 5 is 25. All right, so I can either have x plus 2 is equal to a positive 5 or a negative 5, right? Either one of those. And now, so that's solving with the square root method, right? I just did square root on both sides, all right? And the important thing was that I had the square in order to cancel out from, all right? So now I'm just going to solve this. So I have x plus 2 equals 5 and x plus 2 equals negative 5. So now let's just subtract 2 on both sides. And I've got x equals 3. So that's one of my roots. Okay. And I'm going to subtract 2. Remember, nothing changes on the x plus 2 side. The only thing that changes is that positive and negative 5. All right. So here I've got x equals negative 7. So if you were to graph it, and I'm just going to do a little sketch, where x is negative 7 and where x is a positive 3, you should have a quadratic that goes through the x-axis at those particular places. So you can always check your work. There's so many ways to check your work, so take advantage of that. All right, so in the last section, they gave us a perfect square trinomial. They gave us that square, right? When I did the area method, I could see, in fact, oh, no, I erased it. I forgot about that. But I could see that this perfect square trinomial gave me that perfect square where I had x plus 2 on the top and x plus 2 on the side. All right. In these problems, it's not so easy, right? I don't have a perfect square trinomial that makes it so easy to do that. So I have to make or complete a perfect square trinomial. All right. So here's how I do that. I make sure that the x squared term and the x term are on the same side of the equal sign. Okay, so here I'm just going to move this 18. Let me take that away so it doesn't look like division. I'm just going to subtract 18x on both sides. And the only reason for that is I want the x squared and the 18x on the same side. I also want the x squared to be positive, so that's why I'm moving the 18x. All right, so 18x minus 18x, those cancel out. And here I've got no like terms, so I've just got to write it x squared minus 18x plus 71, right? Because I got that 71 there, equals. And on this side, I'm left with a negative 9. Okay. All right. So now, again, I want to create that perfect square trinomial. So what I'm going to do is I'm going to take these two terms and I'm going to make a perfect square with them. So the first term always goes in the first box. Now, these two boxes have got to be the same exact number. So I have two boxes. I'm going to take this negative 18x and divide it by 2. I'm just splitting it in half. All right. So I have negative 18x divided by 2. That would make negative 9x go here and negative 9x go here. All right. So I just took this and I divided it into 2. All right. So I took negative 18x and divided it by 2. All right. So now if I'm looking for factors, right, that would give me a perfect square trinomial, I would have x times x. And here I'd have negative 9, right, because x times negative 9 would give me that negative 9x. And the same thing over here. X minus 9, right? So negative 9 times x gives me this negative 9x. So I've got x squared, and negative 9x minus 9x gives me negative 18x. So I'm not worried about the other terms, just those two right now. All right. Now, I want to fill this out. I want to complete the square there. So think about how you might do that. All right. Remember, if you want to find out what's inside of the box, right, then you have to multiply what's above it and what's to the side. So I would have negative 9 times negative 9, which would give me a positive 81. All right. So what do I do with that, right? That was not, I don't see that here. I don't see that. I don't see 81. Okay. So I need to now rewrite it. So I'm adding, I'm adding 81, not 21. I'm adding 81, the amount I needed to complete my square. I'm adding 81 to both sides of the equal, right? So it's still balanced. I'm going to add it to both sides. I am going to erase this square. So take a picture, put it on your notebook. Remember to upload it in the note tracker. All right, so I'm going to erase this. Okay, and I'm just going to write on the side, we had factors x minus 9 on the top, x minus 9 on the side, and that equaled x squared minus 18x plus 81. And that was what I needed to complete the square, right? The other two things I have, right? I have x squared, I have negative 18x. This is the only piece that I just pulled out of nowhere, right? Okay. All right. So let me rewrite this. So I have x squared minus 18x. Okay. Now I'm going to put plus 81. And I'm going to do it the same on this side, plus 81. Okay. Now I can't forget, I already have 71 on this side. I already have negative 9 on that side. Okay, so I can't forget that I have those just given in the problem. The only thing I'm changing is I'm adding 81 to both sides. Okay, all right. So now I know that this is my perfect square trinomial right there. So I'm just going to rewrite that with the factors that we found earlier. X minus 9, and instead of writing x minus 9 times x minus 9, I'm just going to put x minus 9 squared. Oops, that is not a great squared. Okay, x minus 9 squared. So that takes all of this perfect square trinomial, and I'm just rewriting it as its factor squared. So now I'm just going to add 71 equals, all right, so I got the plus 71 here. And now I've got to combine these like terms over here. So I've got -9. Let me see. Can you do that in your head faster than I can do that in my head? -9. I think that's like 72, right? Because -10 would be 71. Yeah, 72. Okay. So here I've got a positive 72. All right. So I can't do the square root on both sides until I have the term that's squared by itself. So I just need to subtract 71 on both sides. And I've got x minus 9 squared equals 72 minus 71 is 1. All right. So finally, now we can do the square root method, right? So we've completed the square. We have gone from having just x squared minus 18 to doing that, doing the box, finding those perfect square factors, that perfect square trinomial, right? Right here, perfect square trinomial. All right. And so now finally, we've got a term that is squared. So we're going to do square root on both sides. All right, so I do square root. Remember, that's a positive and a -1. All right, so now, of course, I'm going to have to erase more. All right, so let's erase this. Okay, so I've got x minus 9 squared equals 1. All right, so let's take it from there. All right, so I'm doing square root on both sides. Here I've got a positive and a -1. So the square and the square root cancel out, leaving me just with x minus 9 on this side. And over here, remember, 1 times 1 is 1, right? So 1 times 1 is 1. And -1 times -1 is also that same +1, right? So x minus 9 can equal 1, and x minus 9 can equal -1. All right. So remember, the x minus 9s don't change at all. Only thing changing is a +1 and a -1. All right, so now I'm going to add 9 to both sides. X equals 10. So when I graph my quadratic at 10, I will have an intersection with my quadratic. And let's see what's happening over here. +9, +9. So -1 plus 9 would give me x equals a +8. Oh, so they're kind of close together, right? So it's kind of like a more narrow one, right? So we've got something like that. Right? And that's just a sketch. So remember, these are factors. That's factored form. And these are the roots. They are not the same thing. All right, it's a good distinction to make. All right, so Regents connection. So you're going to follow the same steps that we did the last time. I'm going to go through it a little bit quicker this time. And remember, you can always stop, pause, rewind. So I look at this and I realize, hey, the x squared and 6x, the x term, are on different sides. So I want to fix that. So I'm just going to rewrite it over here. X squared plus 2. So I'm going to subtract the 6x just because I don't want them to be on different sides. Okay. So here I've got equal to 0. The 2 just comes straight down. These are not like terms. So I just need to write x squared minus 6x. Now, if you want to move the 2 over, great, move the 2 over. But, we can do that later too. So I'm taking my x squared and my 6x, that -6x, and I want to create a perfect square trinomial. All right, So first term goes in the first box. We are going to split this in half, that 6x in half. All right, so I get negative 3x here and a negative 3x here. All right, so I have x squared, and I have negative 6x in the form of negative 3x minus 3x. Okay, so now let me write out those factors. X times x is x squared. X times negative 3 would give me that negative 3x. And same thing, remember, we're looking for a square. If there's anything different, that's not going to help me complete the square. So now I've actually got to complete the square. I've got that blank right here, right? I got the blank right there. I need to complete it. That's why it's called completing the square. So negative 3 times negative 3 is a positive 9. That 9 is what completes the square. And by square, it means perfect square trinomial. Okay, so I have the 9. I'm just going to add the 9 to both sides. Okay, a lot of people want to then say 9 plus 2, but I'm not doing that. I'm keeping the perfect square trinomial separate, right? So let me just write that out. X squared minus 6x plus 9. Look at that. I got my perfect square trinomial. And now I'm going to just combine everything else. So I've got plus 2 equals, and 0 plus 9 is 9, right? So these two guys are separate from my perfect square trinomial. Okay. Alrighty. So now I'm going to rewrite this perfect square trinomial as x minus 3 times x minus 3. Or actually, would you mind if I just write that as x minus 3 squared? Now I'm going to bring down everything else. Plus 2 equals 9. All right, so now in order to do the square root on both sides, I've got to get the term with the square all by itself. So I'm going to subtract 2 on both sides. Some people like to do this earlier. If that's your jam, go for it. Okay. All right. So now I've got 9 minus 2 is 7. These two had canceled out, and I'm left with x minus 3 squared. And we actually don't even have to go any further because that's an intermediate step, right? Because we could go further and square root both sides, right? But an intermediate step would be x minus 3 squared equals 7. And I will say one thing. This is a complicated method, but once you do it quite a lot, some people actually prefer it. They find it a little easier to see. So if you find yourself confused, know that you are like with 99% of people that learn this. But keep going, because once you get used to it, it is actually not as difficult as the first lesson. Okay. All right. So hang in there. You guys are doing so good. I know it's just bizarre that we're not going to be in person for the rest of the year, but there's still a lot to learn. So if any point in time you need help, please reach out. Email me or Mr. Q if you're in class with both of us. Contact each other, talk about it, use the Google. There's so many YouTube videos on all of these math topics, so many resources. Practice it, do that productive struggle, right? And you'll get there, all right? Remember, we have a test the first week of May. I'll give you the exact date as we get closer. But keep practicing, guys, and let me know if you need anything. I will see you tomorrow. Happy Wednesday.